So hi guys, good evening all of you. Are you audible guys? Are you audible? Okay, right guys. So the next topic in your SQL. Partition table. Partition tables. So generally, partitions. Okay, why we need to create partitions on table? Okay, now, and what is the purpose of to creating partition tables means? For example, let you observe. Suppose for example, one audio shop was there, for example. Okay, one audio shop was there. So in this audio shop, okay, the audio shopkeeper, okay, the audio shopkeeper, he was maintained one rack. He was maintained one rack. Okay, now he was maintained one rack. And in this rack, okay, in this rack, okay, so he was maintained one rack. In this rack, in one single rack, so all different languages, okay, all different languages, audio DVDs are there. For example, okay, Hindi language movies are there. Okay, Telugu movies, like okay, so English movies, like okay, Tamil movies, okay, like Malayalam, like this. So in the audio shop, what it was happened guys here, all different languages, the movie DVDs, okay, or series or DVDs, whatever. So this all different languages DVDs are keeping under one single rack, and he will be maintained like this. So once he was maintained like this, what it was happened, for example, one customer is came, this customer, for example, he was okay, one Hindi customer is came now. He was one Hindi customer is came now. So Hindi customer, they wanted some Hindi movies or Hindi audio cassettes, whatever it is. So what he was going to be shopkeeper. He was going to be shopkeeper, and is asking. So I wanted some Hindi language movie DVDs or series. I wanted. So then what it was happened? Shopkeeper is telling to your customer, okay, so go to rack, and in that rack you have your movie, your language related movies or audios, okay, DVDs are available. So then this person, what it was happened, the customer, he came to rack and he was searching entire the rack. So he was searching for your required movies purpose, your required language movie purpose. He was searching entire rack. So complete rack is searching. So searching, researching. Finally, whatever he wanted, that he got it, and he was leave from the shop. Again, suppose another customer is came to shop. Okay, now another customer is also came to shop. Suppose this customer is a Telugu customer, for example, is a Telugu customer. Suppose Telugu customer. So he's also coming to your shop and asking to your shopkeeper, and shopkeeper telling to customer, go to check in the rack. So he will come to rack, and he is also searching entire rack for his required movie purpose. So what it was happened here, a specific language, the movie DVD, if I want to take from this rack, so what customer is going to be doing, he was searching entire rack. Because of reason why he was searching entire rack means there is no proper systematical, okay, arrangements are not there in this shop. So all languages are they kept into one specific or one single rack. So that's why any language movie DVDs, if you want it, so that particular language person, they have to go and search entire rack from top to bottom. Okay, na? So when you have searching entire the rack means automatically time consuming process. First thing. First thing is what now? Time consuming process. Second thing is what now? Your performance wise also degraded. That means every time you are going to searching automatically, your performance also degraded. So it's a low performance. Okay, searching time is increased or time taken process to get your required your required cassette or DVD. So this is a lot of problems we are creating when you have to search entire the track. So to overcome this problem, what your shopkeeper is going to be do now, what your shopkeeper is going to be do now. Okay, now, so now he want to go to the same shopkeeper. Now he was planning now. Okay, some audio or video shop. And the shopkeeper, now he was going to be maintained like this. Now this time what he did, whatever the rack was there, this entire the rack is going to be divided or splitting into some parts. Okay, so this entire rack will be divided into some parts. Okay, now in this the three partitions he was doing, that is three parts divided. So this is partition 1, like a P1. So it's a completely Telugu related movies are there. In second partition, now he have it some Hindi related DVDs are there. And the next partition P3, we have here English related movie DVDs are there. So that means what he was doing here, the rack will be divided into three parts. Okay, na? The entire rack was divided into three parts. So Telugu is one part, Hindi is one part, English in one part. And as per the divisions, Telugu rack, Telugu related movies, Hindi means Hindi related, English means English related things are there. So whenever you want to properly, systematically, if you maintain in your shop, if you maintain like this, what it was happen guys here, customers are very happy for that. Because the same thing, suppose one Hindi customer is came to your shop. Suppose one Hindi customer is came to your shop. So he came to your shop. Okay, he came to your shop and asking to shopkeeper, I wanted some Hindi language movies. So where it is? Then shopkeeper is responding to customer. So go to rack. In the rack, second the division is a Hindi language. So what it was happened, as per the request of your shopkeeper, this Hindi customer is directly going to division number 2, and that means he was searching his required movie related cassettes. He was searching under this rack, this division only. So that means this Hindi customer no need to search partition 1, no need to search partition 2. He was directly searching his required partition, whatever he wanted. That means once you divide your rack into multiple parts or multiple partitions, multiple divisions, it's very easy to customer to find their necessary information quickly and fastly, because the customer is not necessary to search entire the rack, is not necessary to search. He was searching only what he wanted. Directly he will go to that specific partition of, okay, the specific partition in the rack, and searching is necessary requirements. So in such a case, what happened, time is saving. First thing is what, no, we will save our time, because we are not searching entire rack, we are searching only a specific partition, a specific division, a specific part we are searching. So that's why automatically the time will be saved and performance will be good, and you will be getting your required things very fastly. Yes or no? So this is what we called as. That means you're simply saying here, searching entire the rack is time consuming instead of searching a particular portion, a particular partition, a particular part. So how we can say this, guys, here? General example, your understanding purpose. Same to same. Now you have a table. This is your table. This is your table. Okay. Suppose this table is having, there are 1000 rows are there. There are 1000 rows are there. But this table, 1000 rows are there in this table, but this table is not partitioned here. Then what happened? For your user required data purpose, he want to come search a entire table searching. That means how many rows? 100 rows searching. That means entire table is searching. So searching entire table automatically time consumer process. Okay, no? So when your table is having a big data, the very large scale data was there in the table. From that big data, if I want to retrieve some specific data, then what we want to do, that entire table we need to search. So that automatically time consuming, low performance will. Okay, now? So to overcome this, what it was happening that here, people, what they will go to do, they're going to be dividing your table into partitions. Okay, this is partition 1, suppose this is partition 2, okay, and this is partition 3. So your table is also divided into some partitions, and based on the partition how you create it, based on which conditional basis your partition is divided, based on that your data will be stored, and based on that your data will be retrieval. Okay, now, so if you want to retrieve my partition P2, then I can directly, I'm writing a query directly to retrieve data partition P2. That means partition P2 data searching and retrieving, but it doesn't go to partition P1, it doesn't go to partition P3. Okay, so partition P2 immediately we are retrieving. Okay, now, so this kind of advantage, time saving, searching time will be reduces, performance will be good, performance will give to us. Okay, now, so this kind of advantages are there. Okay, partition tables. That's why simply what the people are saying here, what they are saying here, generally partitions are created generally partitions are created on a very large scale database, very large scale database table or table. Okay, na tables for dividing into multiple okay, multiple parts, okay, multiple parts or units, okay, for dividing into multiple parts or units, okay, and each unit is called as a partition, okay na? So this is the main reason. So partition means general partitions where we want to create or where we want to create means when we are working on large scale tables. That means when your table is having very big data or large scale data was there in your tables. So from that large scale data tables, suppose you need to retrieve some specific data. Okay, at the time we need to set that entire table is a time consuming. So that's why the people what they will do, they're creating partitions, okay, na, on your table, and based on that they can store, and based on that they can retrieve the data with the simple and easiest way and manner. Okay, na? Right. So this is what is the need of partition. Okay, we got. But in our Oracle, there are three types of partitions are supported. First one we can say range partition. Second one we call as a list partition. Third one we can say hash partition. So these are three types of partitions. Okay, we have it here. But let you see one by one how to create these partitions. Okay, first one, let me go for range partition. Basically, in this method, the partitions are created. Based on a range value. So particular range wises you can create your partitions. Okay, na? So that's why it is called a range. So whatever the range value was given by user and programmer at the time of partitions creation. So based on the ranges, your partition will be divided here. Okay. Now how to create a partition? The range partition creating, okay, same as this. First you have to create your table as usual. Column name, data type, size, comma, column key, data type, okay, size, comma, and so on. Okay, so if you terminate here, generally what happened, a normal table is created. When you terminated, a normal table is created. But don't terminate this table. Now this table have to do partition now. So there you can use a partition by range. That means which partition are you created, that partition statement should be right here. Okay, now? Right. So partition by range. Okay, now? Range. And this partition are you doing on which column? Here, column name should be passed. After that, how many number of partitions you want to create? So then prepare partition name 1 and sending values sending values which is less than of a value. Okay, now, comma, partition, and now you can pass here partition name to, okay, values less than of a value, comma, and so on. So like this, number of partitions you can create on your table as per your requirement wise. Let you see some examples. Okay, right. So first of all, I want to add my database tables. One, whatever, some unnecessary tables I'm dropping, guys. Okay, right. Now, so first example of the create table name text one, create table name text one, EID, E name, so few columns I'm taking, okay, and salary, okay, and salary. So this is table. So are you created table with your required columns? Okay, how many number of columns you wanted, you can create. After that, you need to add your partition. So the statement is what now? Partition by range. So that means which partition are you created? Range. On which column? Salary column. On which column? Salary column. Of, now you can prepare your partitions. Partition 1, values less than, okay, less than offer. Suppose I'm giving here 1000, I'm giving. So values partition P1 values are what now? Less than 1000. Less than 1000 means what now? 0 to 999. Yes or no? Less than 1000 means 0 to 999. So 0 to 999 salary range values storing under P1. Storing under P1. Okay, now that is the main here. Next, okay, comma. Suppose second partition. Partition P2. Values less than offer. I'm giving here suppose 2000. Like partition P3. Values less than like a 3000. Okay, so now these are the partitions. So now I'm creating the three partitions with three range values. So 0 to 999 P1 partition, 1000 to 1999 second partition, 2000 to 2999 third partitions. Okay, now up to this we are going to be created. So now the table successfully created. Okay, right? And later after that I'm inserting some data. Now I'm storing some data. Employee ID 1021. Some name is Sai. His salary 2500, for example. In the same pattern, some more records 102. The name is Jones. His salary 500 rupees. 1023. The name is what? His salary 850. He was in that. 1024. His name is what? Okay, here's the salary. For example, 1500. So he want. So like this, he will be inserting as the ranges. He was inserting data, and whatever the data are inserted, same to same as per your salary ranges. That particular information is storing under particular partitions. Okay, so 500, 850, it's the first partition, it is a second partition, it is a third partition. So once your data storing into partitions wise, okay, now suppose your data storing into partitions wise, then what is the advantage of the user? Means now which partition of data you wanted, that particular partition directly you can call. But how to call here? Syntax to call. Syntax to drive. Call a particular partition. Okay, a particular partition data from a table. So what is the syntax? The syntax is select a star from table name partition. Select a star from table name partition of. Here I want to send partition name. Here I want to send partition name. So this is how the range partition is created and how to call, okay, your particular partitions based on your range values. Okay, now suppose I need partition P2. I need, so I'm passing number 1. So partition I'm passing P2 if I'm passing. So in this P2 partition, okay, partition means small unit. In this P2 unit, whatever the data is stored, the data immediately was retrieved. So that means you are asked your request, your server will go to directly that partition P2 and retrieving the data from the table. So that means what happens, server is not searching P1, not searching P3. So P1, P3, no need to search now because I'm directly asking to my server, I wanted P2. So immediately the P2 information is shared or sent back to your user application. So it's not necessary to check your partition 1, is not necessary to check partition number 3. Okay, now it's not minded. So then automatically time saving, performance wise good. Okay, there is no delay. Okay, now so this is what advantage now. Same to same, if you wanted partition number, suppose P1 I want it, then just a partition name you can pass, partition of data you want it, the partition you can pass. So it was coming out. Like in the same to same P3, okay, like it is coming out. So this is range partition, guys, here. How to create a range partition tables and how to store and how to retrieve a particular partition of data from your table. Okay, now so this is range partition, how to create. Okay, now right. In the next one is this is range. What about your next list partition? Next one is what now? List partition. So list partition, okay, how it was going to be work. How it was going to be work. Okay, now right. So now let me come out. List partition, okay, these are created. That means partitions are created based on list of values. Based on list of values, how it is. For example, here syntax is also same, guys, here. Okay, the syntax also same, but only the partition statement only. Here partition by range, but now I want to give partition by list. And again, column name, on which column basis are you created? Later partition P1 values, partition P1 values. Okay, then you can pass your values, some list of values you can pass, like value 1 comma value 2 comma value 3, like you can pass it. Okay, in the same to same, next one is partition, and now I want to send partition name to and sending values of, then I'm sending values of value 1, value 2, value 3 comma and so on. So like this number of partitions you can create, guys. And finally, partition others. Finally, partition others and passing values of, here the values are default values, so that means other than partition values. If any other value we can insert, that will be storing under others partitions. Others partitions. So this is list partition syntax to create. Okay, right. Same to same, come out here. Now, let me create as usual one new table. Create table, that's number 2. Suppose I'm passing here serial number integer and course name. I'm passing marker 2 of the site. Later, I'm passing here partition by list and here column. Column means, okay, course name column. Okay, later we are passing partition course one. Next we are passing what now? Partition 1. Sending values of, so we are passing C++. Okay, I'm passing these two courses comes under partition P1. Okay, now comma. Next one is partition P2. Sending values. So we're sending values is Oracle, comma MySQL. Okay, MySQL. So this is second partition I was saying. Next, partition others. Others and sending values of, what is that? Default. What is that? Default. So like you see, the list partition table is created, and after that you want to insert now. Insert into test number 2 values, serial number 1, and we are passing Oracle. Okay, then Oracle is successfully inserted. Serial number 2, I'm passing Java. Serial number 3, I'm passing .NET. Serial number 4, I'm passing C language. Serial number 5, I'm passing MySQL. Okay, serial number 6, I'm passing C++. Okay, so like this. Finally, when you come to test2 table, this is your test2 table information. And again, same to same, a particular partition you want it here, then as usual, you're calling. Select star from test number 2, and I'm using a partition of suppose P2, I'm asking now. In P2 partition, what it was there, Oracle and MySQL. So how you design your table with the partitions, same like this, it will be returning us. In the same to same, suppose if I'm asking the partition number P1, if I'm asking, then P1 partition data, C++ will come to us. So if I'm passing partition, what is my partition name is others. My partition name is others. Others means other one, Java.NET. Okay, now? So this is list of values. Okay, on this list of values, we are dividing into partitions and storing and retrieving. So this is list partition we called. In the same to same, the third partition is called as what now? Hash partition. Third partition is called as what now? Hash partition. Okay, right. So now as partition, what happened? So in this method, partitions are created. Partitions are created by system automatically. Okay. In this method, user is not necessary to create, guys, here. User is not necessary to create here. Okay. So user just giving how many number of partitions you wanted. That number we are specified, but created by system automatically. Okay, as per user request. So this is hash partition method and mechanism. Now come to syntax. So in this also same system, the table we are going to be taking now, and this is your table information, number of columns, how many you can go to proceed, the number of columns here. After proceeding this, okay, here in the syntax, what was it? How many partitions you want to create? So that you have to tell it. So now I'm passing partition hash of as usual column name. And after that, you just pass it here. Partitions. That means how many partitions are you wanted? Just a pass number. How many partitions you wanted? Just a pass number. Okay, now understand now? Right. Suppose, for example, you can see. Example. Are you created one table? That's number 3. Some serial number, income, child number. And now, okay, we are going to be created partition by hash of the column in salary. And here I'm passing partition, suppose I'm giving 5. So your user request is what now? How many partitions you need to create on test 3 table? Okay, so the user request is 5. So based on the user request, internally, your system is going to be created 5 partitions because your user is asking 5. So 5 partitions are created. 5 partitions are created. And now let you see to execute, table is created. But your 5 partitions are created or not. Suppose you have to see it. Okay. I want to see partitions are created or not, means there is one data dictionary you have to remember, that is called a user underscore tab underscore partitions. One data dictionary, you just follow. So in this data dictionary, you have your partition name and table name. Okay, let you see. Let you see. Now I'm select partition underscore name from user underscore tab underscore partitions. Okay, now where table underscore name is equal to which table I have to see text number 3. So now we can see on text number 3 how many partitions are created by system means partition P21, partition 22, 23, 24, and 25. And here SYS, SYS means what now? System defined, system created. So user is not created. User is just giving number of partitions, how many you want it on a table test number 3. The number I'm passing based on my request, system is created total 5 partitions. That's why you can see SYS. SYS means system defined. Okay, now? So that is what 5 partitions. Same to same, if you want to see, suppose the previous 2 tables also we create a range and list of partitions. Suppose I was giving test number 2. The test number 2, I will create 2 partitions, P1, P2, and others. Suppose if you want to see in test number 1 table, how many partitions we create? P1, P2, P3. So that means on a table, how many number of partitions are you created? That information we can save by using of user underscore tab underscore partitions. So this is one data dictionary, guys. But these partitions are, guys, here we are created along with the table creation we created. But how to create a partition on existing table? On existing table. The existing table means adding a new partition. Adding a new partition to an existing table. To an existing table. So already table is there, but to existing table, how to add my partition? So which partition you want to add? That partition logic, like range partition logic syntax you apply. List partition syntax you apply. But as partition we can't add because as partitions are created by system. Okay, now so that's why we cannot add that. So now these are list and range partitions you can add. So how to add? Suppose come to here. Test 1 table already having 3 partitions already there on test 1 table. Test 1 table already having 3 partitions. So now I want to create one more partition on test 1 table. Okay. Then what is the syntax to add your test 1 table partition is up there. So which partition are you adding here? The partition syntax will be remembered. So alter command compulsory. Alter table name. And what we are going to do, add what we are adding partition. What we are adding partition. And what we want to do, partition name. And send values, suppose less than of a value. So less than of value. So this is what now range partition. Okay, this is what now range partition adding. Okay, now range partition, because here it is a main. This is the main. This is the main. So if I'm giving values less than value, that is a range partition. Suppose if I'm going to remove this values, if I'm giving this values of value 1 comma, value 2 comma, value 3 comma, and so on. This is what now, guys, here. This is called as a list partition. So with a range or list, which partition you are adding, based on that particular syntax you have to use. Okay, now right. So now this is what. Suppose I need to add a range partition. So values, okay, less than of value. Suppose. Okay, right. Now let you see. Test number 1 already, okay, 3 partitions are there, P1, P2, P3. Now I'm adding. Alter table name, let's add partition P4. Partition P4. Values less than of some 5,000 I'm giving. Less than of 5,000. So now I'm adding this partition to our table. So table successfully altered. After altering, let you see if you want to see your partition. So now you can see test 1. Now how many partitions are there? Total 4. So 1 partition is successfully added. So this is how to adding the partitions to existing table. Same to same, how we are adding here, same as usual, we need to drop also. Drop a partition from a table. So adding and dropping partitions here. So what is the syntax for your dropping partition means? Alter table name. Drop I'm using. Which keyword I'm using? Drop keyword. Of what I'm dropping here? Partition. And you just pass it here. partition name. Any partition you can give and drop. Suppose in this P1, P2, P3, P4 was there. Okay, now if you want to drop, how to drop? Alter table, the test one, drop partition. Suppose I'm passing P2. So table is dropped. Now later you can see your P2 partition is dropping or not. Let you see your P2 partition is successfully dropped. Okay, now? Right. So now what happened here? What happened? Now you can see partition P2 successfully dropped, but partition P2 data is also deleted. Understand now? Once you deleted your partition, automatically that partition data also deleted. Like you can see 1500 is not there because 1500 I was inserted now. 1500 is not there. So now which partitions are there? P1 partition data is there. P3 partition data is there, but P2 partition data not there. Suppose in the same to same, let you come out and see. Suppose I'm giving here P1, I'm dropping one. Let me come out here. P1 is dropping means your partition P1 is successfully dropped. Okay, but P3, P4 is there. But now you can see partition P1 data also dropping, and only 2500 only left. So that means once you drop your partition, in the partition, whatever the data we store, the data is going to be automatically data also deleted. Okay, now? So these are partitions, creations, adding, dropping. In the next one is what now? Suppose there are so many tables are there in my database. Suppose I want to see EMP table is there, for example. This EMP table is partitioned or not. Suppose I want to know the EMP table partitioned or not. That I want to know. How I knows this table is partitioned or not. How you knows means there is one more data dictionary is there. The data dictionary is called as a user underscore tables. Okay, now? The user underscore tables. Now this data dictionary, if you want to use, so there are so many columns are there in this data dictionary. But in this column, one of the columns is called as what now? Where it is, yes, partition. So one of the column is called as what now? Partition. So this is I have to call. So select partition. Okay, now select a partition from user underscore tables. User underscore tables where table underscore name is equal to suppose EMP. So now I want to know it. EMP table is partitioned or not. EMP table is already partitioned or not. Let you see to execute. So what it was saying, guys, EMP table is not partitioned. No. So what it was telling? No. EMP table is not a partition table. No. Understand now? Suppose another table I want to see. DEPT table I have to see. Is it partition table? No. DEPT table is also not partitioned. Okay, right. Suppose if I want to say test1 table is a partition table. Yes. Test1 table is a partition table. Yes. So now it was showing yes. Test2 table, partition table. Yes. Test3 table, is it partition table? Yes. Okay. So this is the way how you knows my table is already partitioned or not. So that you have to check it, guys. Okay, now. So these are partitions. Is a very small topic in our SQL part. Okay, just how to create partitions and complete notes I'm sending. Once you have to practice, okay, you will get some idea. Okay, now, right. And next one is The next topic is sequence. The next topic is sequence. So what is sequence? What is sequence? What is sequence? Okay, now sequence is nothing but simple observation. It is a database object. It is a database object which is used to generate sequence numbers, to generate sequence numbers on a particular column, automatically, on a particular column automatically, without user interaction. So without user interaction, automatically your sequence numbers are generating on your particular column. So whenever you want to go for that kind of facility, if you want to apply on your table, so there first we need to create a sequence objects. Once you created sequence object, and that object you can apply on your table columns. So on which column you applied here, in that column, automatically your sequence numbers are generating by your system with the help of sequence facility. Okay, now so that is what sequence object purpose. But this sequence, if you want to create, so what is your syntax to create your sequence object? What is your what we can say syntax to create your sequence object? Okay, now you can observe. So create sequence, sequence name I need to pass sequence name. Okay, and later we have some parameters. So the parameter is called as a start with n. Second parameter is called as a min value n. Third parameter is called as a increment by n. Fourth parameter is called as a max value n. Next parameter is called as a no cycle or cycle. The next parameters are no catchy or catchy. Yeah. Okay. So these are the sequence object whenever you want to create in your Oracle database. So this is your syntax of sequence, how to create it. Okay, now. So what is there? So the sequences are having here. Okay, now. So some few parameters are there. Start with parameter n and the minimum value parameter n, increment by max value, no cycle, no cache. These are all are called as a parameters. And every parameter is having some specific reason and purpose. What is what we will check out here. First one is start with n. So start with n parameter. What it was saying means it is specified. Okay, it specified. Okay, starting sequence number. Okay, so start with parameter specify starting sequence number. That means your sequence number starts with the which number? Your sequence number starts with the which number? Okay, now that is represent. And here, what is n? N means simply we can say number. N means simply we can say number. Okay, now right. So now this is what. Second one is min value. Min value and the second parameter. Min value, what it was specified. It specified minimum value in the sequence. Minimum value in the sequence. Okay, so here also same common here. N is nothing but number. So minimum value. Next one is what now? Increment by n. What is increment by 1 means? It specify incremental value in between sequence numbers. Okay, here n also, n is nothing but number. Okay, now next one is called as the max value. So it specifies, okay, specify maximum value in the sequence. And here also n is nothing but representing number. Okay, now. So these are start with minimum, increment, maximum parameters. Next one is called as a cycle parameter. What is no cycle? No cycle parameter is a default parameter of a sequence object. Okay, it is a default parameter. But when we create a sequence object with no cycle parameter, then the set of sequence numbers, the set of sequence numbers are not repeated. It is not repeating here. It is not repeating, okay, or not repeated. Okay, not repeated. So what it means? For example, let us see. Suppose are you giving here sequence is created, start with 1. Okay, suppose are you creating start with 1, min value 1, increment by 1, max value suppose. So I just close my sequence. The semicolon means end of the statement, end of the syntax. Okay, right. Suppose in this example, observe, I'm not using cycle. I'm not using cycle means by default what? No cycle. I'm not using cycle means by default what? Cycle. Okay, now by default what? Sorry, I'm not using cycle means by default no cycle. By default no cycle. So suppose are you created your sequence object based on these values. Okay, what it was happened now? Your sequence will be generating like this. First the sequence start with 1, second sequence number 2, second 3. That's it. So this is starting sequence and it is only minimum sequence value. Increment 1, 1 plus 1, 2, 2 plus 1, 3. And your maximum value what now? 3. So are you reached your maximum value? Yes? Yes or no, guys? Are you reached to your maximum value? Yes or no? Okay. So once you reach your maximum value, again your next sequence number is not generated, and also the same set of sequence numbers also not repeated, because the sequence is created with the no cycle by default, no cycle. So that's why starting 1, increment 1, 1 plus 1 2, 2 plus 1 3, and maximum value 3. So once it is reaching to your maximum value, once it is reaching to your maximum value, okay, once it is reaching to your maximum value, then your sequence will be stopped. That means your sequence will not generating. Why it is not generating? Because you already reached to your maximum value. Whatever the maximum value given, that maximum value already reached. So once you reached your maximum value, then there itself your sequence numbers are stopped, and next sequence numbers are not generated. Okay, now this is no cycle. This is no cycle. Suppose, what is cycle? See, if you are writing like this is our output. This is your output. Okay, now keep it that output. Suppose, are you creating cycle? Now we are out. In this, what happened? When we create a sequence of cycle with cycle parameter, then the set of sequence numbers, the set of sequence numbers are repeated again and again, okay, repeated again and again. Let you see examples. Suppose, are you created this? Are you created this? And now I'm using what now? Cycle. Suppose I'm using cycle, and my query end statement is end. So when you create your sequence with cycle, then what is your output? You can see. What is your output means? Yeah, your sequence generated 1, starting value, next 2, increment 3. So this is already reaching to your maximum value. Yes or no? Are you reached to your maximum value, guys? Okay, are you reached to maximum? So once are you reached to maximum value, again that means here what happened? One cycle is completed. It means what now? One cycle is completed. Then again your sequence numbers are generated. Again generated 1, 2, 3. Again 1, 2, 3. Again 1, 2, 3. So like this, it will be continuous process. Okay, now? So once you reach to your maximum value, then one cycle is completed, and again one more cycle started. Again one more cycle started with what? The minimum value 1. So minimum value 1, 2, 3. Again one cycle is completed. Again one cycle is completed, and again we started new cycle. Okay, now? Again we started new cycle. One cycle completed. Again new cycle. New cycle started with again minimum value 1, 1, 2, 3. So again one cycle completed. Again new cycle started 1, 2, 3. So it will be like this, and there is no stoppage. You can't stop it. It is infinity. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So how many number of rows the user is inserting? how many number of rows data the user is inserting into table. For every row purpose, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 is a unstoppable infinity. It's a depending on your number of rows. Suppose you are inserted 100 rows, then it is 1, 2, 3, 1, 2, 3, 1, 2, 3, 100 times it will be. That means 100 rows, 100 sequence numbers are generated. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so it's a depending on your inserting rows. If you inserted how many number of rows, that many times your cycles will be started. That means the same set of values, set means group of values. The same group of values, if you want to repeat again and again, the same group of values, if you want to repeat again and again, so there we can use a cycle. Cycle means repetition, life cycle, uncountable, unstoppable. That is called a cycle. Cycle means what? Round, circle. Yes or no? Life is a cycle. Yes or no? There is no stoppable. End of your whatever that death, whatever it is, until you're not stoppable. Okay, now so this is what it is. The cycle means a repetition of set of values. Okay, right. And the next one is cache. So cache and no cache. So these two parameters, what is what? So we will discuss in tomorrow's session, guys, here. So tomorrow we will go for what is cache and what is no cache. Okay, now? Right, yes. Thank you. Thank you so much.